All right, welcome back. We're going right into chapter 12, structural metals, starting right on page 163. First of all, what is metal? In all these welding processes, you typically see that M, shielded metal arc welding, gas metal arc welding. What is metal? Well, we typically break this into two categories. You got metal, you have non-ferrous, and ferrous metals. Well, anybody that's been in chemistry, do you know what iron is represented on the periodic table? Iron is Fe. That's how it's represented on a periodic table. So you start looking to the different two types of metals that we're going to focus on, and you'll get a lot of this in metallurgy. Non-ferrous metals, no iron. There's no iron content. So non-ferrous metals are like your aluminum, copper, things like that. Ferrous metals contain iron. Your metallurgy class will go in great detail of these types of metals. We're not going to do that in our print reading class. So when you see metal, this is a big thing. Non-ferrous, ferrous. Typically your non-ferrous metals that you guys are going to be welding on is aluminum. That's what we're going to weld here in the college. And you'll get into that. So it contains no iron, is non-magnetic, things like that. And that's going to determine your weld station setup. Those that have been in GMAW class, you're going to use like a pure argon. You're going to use your aluminum electrode, things like that. Our ferrous metals, they contain iron, so it's your typically your base metals, things like that. Your 836, 572s, T1s, all that. Those are all ferrous metals because they contain iron. When you hear of a pure metal, that's a pure metal and it's a pure sense. So it's also called like a base metal. So when they talk about we're going to be using carbon-based metals, so that means there's a lot of iron content, there's carbon in that iron, that's your base metal. We're using aluminum as a base metal. That's what you're going to be welding on. They always say base metal instead of pure. So hopefully that clears things up. As we move forward, structural metals. Pages 184 and 185, they go through the different shapes and the symbols. I'm not going to write them all up on here. You can do that yourself, and as you go through it, and keep in mind you can always use your book for the test. But these are the different types of structures that you're going to see, and they're going to use the symbols used on these pages also when you actually see them. For example, like angle iron, they use the letter L. It's kind of shaped like an L. S beams for your I beams, they use the letter S. So they're going to abbreviate them. Because if you could imagine being an engineer and you start writing every little thing down on that print, it's going to be really cluttered. Really cluttered and really confusing. So take page 164 and 165. Kind of devour that, look at them, memorize them, things like that. The main misconception we have is between pipe and tubing. So as you look at pipe is circular, looks like that. When you look at pipe, they actually measure the inside diameter. If you look at tubing, they actually measure the outside diameter. That's the main difference, because you can have box tubing. So for example, you have box tubing. This could be a piece of 6x4 box tubing. So that's the main thing to really digest in this unit. What's pipe, what's tubing? Because when you go to order this stuff, you've got to understand if you're ordering pipe, it's going to go inside diameter. Tubing is going to be always outside diameter, what it's measured by. So keep that in mind. So kind of go through 164, 165, kind of go through it. And if you notice, it's completely different than what you've been taught. When you go to carpentry, you say 2x4. Well, now we're dealing with metal, so it's a 4x2, and then whatever wall thickness we're using. So as they list the dimensions, it's backwards. For example, you look the hollow structural section of the box tubing there, you see it's 6 by 4 by ½ inch on page 165, halfway down. So you list the biggest dimension first, 6 inches by 4 inches, and then they list the thickness of the material. So that's probably the biggest difference of this unit. Everybody's so used to saying 2 by 4 when they talk about wood. Well, now in metal it's a 4 by 2 and then whatever thickness of the metal it actually is. So a little bit different than you're used to. Won't take long to adjust. Keep in mind pipe tubing, big difference too. It determines where you're going to measure it through. So then again, if you ever have any questions too, ask your instructor about this unit, because this will be on the test of how to measure. There will be structural shapes on your test. You're going to go ahead and measure them and list the dimensions in the correct order. I always start with the biggest dimension. For example, we would list this 6 inch by 4 inch. Let's say that's 3/8 wall thickness. That's how that would be given. And even in the pipe, so I'm going to probably ask you to measure a few pipes on there. You're going to be giving me the inside diameter. Tubing is always outside diameter. Can't stress that enough. So, as we move on, the metal specifications, they may have a material list on your print, some don't. But typically your base metal, as you see in the bottom of page 166, they're saying that in this print they're using steel AI SI 1020. So it's always listed there. Why they do that is because you actually have to determine what type of filler metal is compatible, what type of gases you're going to be welding with that filler metal, and what type of process. So you might do it in a pulse, you might do it TIG welding, however it may be. So knowing your base metal kind of determines how you're going to weld it. So also on page 166, there's many different categories of how to identify base metals. For example, you look at military grade, there's American Iron and Steel Institute, ASME, ASTM. We use a lot of ASTM, like our A36 ASTM, because that's used for testing. So those are just like different companies design their different types of material. There's even one in here for automotive, I do believe, yeah. SAE, Society of Automotive Engineers. So that's what they use in their materials. It all determines where you're going to work and what type of specification they're going to actually use. A lot of these are, they cross boundaries. So for example, you could have the same material and it could be in almost every one of these categories. Same material, but it's listed a little different. The main ones, like I said, we use are ASTM A36, things like that. That's what you're doing all your bend tests with and things like that. I'm not going to get in great detail on that because I said metallurgy, they dive right into every one of those specifications so you can identify base metals. I don't want to waste your time with that right now in print. The main thing I want you to focus on is pipe, tubing, angle iron, your beams, how the dimensions are located and why. Remember, they're a little bit backwards, 6 by 4 instead of 4 by 6, so it's 6 inch by 4 inch, and then they list the thickness of whatever that box tubing is. So on your test, I'm going to have you identify multiple different types of structural metals and make sure you have the dimensioning correct and make sure you're measuring to the right spot. Tubing's always outside, pipe's always inside. So kind of go through the chapter review. Like I said, this is more of a memorization thing, but you can use your notes, use your book. And if you ever have any questions too when you get in the industry, don't be shy to ask your shop foreman. Don't be shy to ask an engineer. And make sure you got your right filler metal that matches that base metal kind of thing. So that's it for chapter 11. We'll move on to chapter 12.